will do for us. So let's be patient. 5 minutes. Thank you. Good evening, everyone, once again, and welcome to today's webinar on the topic AI and the Future of Agriculture from Prediction to Action. With us, we will be dealing with three panelists who will take us through our 1 hour journey to make us understand what AI in agriculture is and what we should look out for in the next 5 to 10 years to come. What exactly is expected of AI's input in our agriculture in the next years to come. So the first person is Papa Kofi Buahin, who is a software engineer. He's passionate about leveraging technology for real-world impact. He also led the Google for Developers on-campus program, and is also a host. He was once a host for the talk. The next person is Erica Ajua Apia, who is an agri-tech innovator, supply chain expert, STEM coach, co-founder and CFO of Wobble Technologies Limited. And our last panelist is our very own founder and CEO of AgriLync Nexus, who is a machine learning engineer, an agriculture innovator, and as mentioned, the founder and CEO of AgriLync Nexus. Welcome on board our able panelists, and we hope you are ready and prepared to take us through this insightful journey. Can we please know if they are around? Papa Kofi, Congo, and Erica.
Yes, I'm here.
Okay, Papa Kofi has responded. Two more panelists to go.
All right. Good evening. I'm here. Congo, I'm here.
Okay, and our first lady. It's Erica with us.
Yeah, I could see her on the call, but I don't know whether.
Yes, she's muted. Okay, so while we wait for her to join us, I think we should give our two panelists some seconds to give us their opening comments before we kickstart. I think by then she would have been in. So we start with Papa Kofi Buahin. Kindly give us your opening comments for today's program. Thank you.
All right. So, thank you for the introduction. So, as she stated, my name is Kofi once again, and I'm a software engineer, and I'm also passionate about using technology to solve everyday problems. Right? So today's discussion is on how we can leverage AI in agriculture. We are going to give detailed explanation on how this can actually be done. We might not be able to give exactly how it should be implemented, but the goal is to help us and enlighten ourselves on the various ways we can tackle challenges in the agricultural sector using technology, and particularly AI. Since AI is an emerging technology that holds a promising future for the world and for Africa too. Yeah.
Okay, thank you very much, Papa Kofi. Congo, can you please give us your opening comments?
All right. So, good evening, everyone, and thank you guys for being here. I know that the slot was it were limited, and it really means a lot that you guys made time for this particular day. So, thank you, Cynthia, once again as well for the good introduction, and it's very good to be with the panel such as Kofi and Erica. And for those who doesn't really know me, my name is Kongo Musadama, and I am the errand boy for AgriLync Nexus, and I have a background in agriculture and also machine learning, but my passion really lies in agriculture. That is
leveraging technology to solve agricultural problems. And at AgriLync Nexus, what we do is simple. We connect smallholder farmers in Ghana to investors. And we do that through finance, training, and AI advisory, where we are going to deep dive into it. And tonight, we are going to move from big ideas, and we are going to walk through what AI actually looks when we actually means implementing AI into our agricultural activities. Thank you once again for the introduction. I'm looking forward to have a wonderful conversation with you all.
Thank you very much, CEO. I don't know. It's Erica with us now. Wow. Okay. So whilst we wait for her, I think we are trying to connect with her. So let's kickstart whilst we wait for her to join us. Once she joins, she will join us from wherever we will be. So, okay. Our topic for today, as we all stated, AI and the future of agriculture. We want to move from prediction to action. Now, to our panelists, in one sentence, what does that future actually look like for you? We start with Papa Kofi, sorry.
All right. Thank you once again. So, what does that future look like?
Yes.
When we say moving away from simply predicting to action, we're talking about using insights to make decisions. So, as we are aware, AI it's a way for us to predict the future from the past. So essentially, what you're able to do is that you're able to train machines to sort of have some kind of intelligence so that they're able to predict the future. But you're only able to do so because you're able to provide the machine with information from the past. So when the AI is actually able to predict the things we need to do, the next thing is for us to actually do it, isn't it? So what it looks like is we actually are applying the insights we gain from these as AI models to actually create change in our society. And as the discussion goes on, I'll show more concrete examples of what you are talking about here. So that it's not just about us talking, but I'll actually show a few videos so that you can all see the practicality of what you are saying. But the goal is that we need to get to a point where the AI becomes an everyday thing and affects us from the farmer to the consumer. Everyone needs to see the impacts that the AI is creating through its ability to predict the future and to give us useful insights that can help us make more informed decisions in the agricultural sector.
Okay, thank you very much, Papa Kofi, for your insights. Let's move to Congo. What does the future of agriculture look like in your perspective?
All right. So when you talk about the future of AI in terms of agriculture, I think most people normally we take it in the wrong way. We normally think when you talk about AI, it's more like the sensors, the drones, and others. Okay, but AI could be something that we can even have on our smartphones. And also, when we talk about the future of AI, we need to think about the farmers that we are trying to deal with. Okay, the experience that they have, that is the user experience. Okay, because these farmers that we are dealing with, we are talking about what smallholder, what farmers. Okay, so if you have to build systems that is AI, we think about system that is what distributable, something that is what will be able to what rate the farmers wherever they are without having any challenges. Let's talk about the network access or the smartphone access. So with the future of AI, it is very interesting, and we are looking at moving from just predicting to prescription. And as we move forward, we are going to know more about whatever that I'm talking about. Thank you.
Okay, thank you very much for that. I think okay, she's not the one. Okay. Yes, so now we move to the main questions for today's topic, and I would like to ask Papa Kofi once again to tell us something about AI, because some of us, especially those who are not tech driven, when we talk of AI, we see it to be a chatbot. What do you think we should look out for instead of seeing AI to be a chatbot? Papa Kofi.
Okay, thank you very much for that question. So that's actually it's a really good question, because I think mainstream AI became introduced to a vast majority of people through what we call GPT, which is actually an LLM, which stands for a large language model. So LLMs are actually just a small part of what AI is, right? Within the AI umbrella, we have a couple of things under it. We have machine learning, we have deep learning, neural networks, and so on. But the point is that chatting with a chatbot is simply one aspect of AI, which is a large language model. And that is more common because you all have access to it through Gemini and through ChatGPT and so on. But AI is broader than that, right? AI is a tool that allows us to effectively make predictions based on past data, as I said earlier. So you can imagine other use cases, like for example, if someone goes to the hospital and does some lab tests, we can actually use AI and supply these lab tests to actually predict whether they are at high risk of getting diabetes or high risk of getting stroke and so on. So it's not always about chatting with a chatbot, but AI is actually a tool that gives us the ability to make predictions. And again, today we have another form of AI, which is the generative AI. It is quite similar to the ChatGPT as we know it, but the generative AI is able to actually create something, right? And not necessarily answer questions, but it's able to create something. So, for example, in scientific research, we want to know the structure of proteins. So AI is able to help us to predict the structure of proteins in a way that's unprecedented, right? In a way that has never been done before. So the direction that AI is going is beyond chatbots. Although chatbots are what we see and interact with most often in our day-to-day lives. But the things AI can achieve goes far beyond chatbots, as I have explained earlier. And today our goal is to explore how we can actually use these things practically in a Ghanaian context to solve some of our problems in agriculture.
Okay, thank you very much. And I think third panelist, Erica Ajua, is now on the call. Welcome, Erica, to today's webinar. Let's give her some seconds to introduce herself and give us her opening comment for the program whilst we continue. Thank you.
Hi, Cynthia. Thank you very much. My network glitched a little, so I think I lost the beginning part. My name is Erica Joapia, and I'm a co-founder and marketing and finance lead at Mobile Technologies Limited. And what we do is we manufacture climate smart agri machines like rice threshers and rain mowers. Yes. And what opening you mentioned that? Is it about the future of
Yes, on the topic.
On the topic, okay. So, for me, the future isn't just about AI replacing farmers, as a lot of us are afraid of that. AI is coming to replace humans and all that. But for me, it's farmers, using AI to make expert decisions in their farming, activities and all that. So then all the post-harvest losses and productivity issues can be solved. Yes.
Okay, thank you very much and welcome once again to today's webinar. I think I will not be fair if I continue with your question, your first question. So I think let me move to Congo, give you some minutes to settle, then I'll give you your first question. So yes, to Congo. AgriLync moved away from chatbot style AI to push AI. Why do you think this is closer to the future you in AgriLync are building towards?
All right. So you made mention of we moving from chatbot style to AI. So
Yeah.
when Papa Kofi was talking, he mentioned about generative AI. He spoke about like we using ChatGPT for our daily what stuff. Great. So the reason why we moved from chat based is because we realized that what we were even designing, most farmers doesn't even know what to ask chat. Okay, so we moved from just building system that's going to make these farmers ask questions to push intelligence, and this push intelligence is something that actually understand the farmers, provide information to the farmers even before they ask a question. Okay, so think of it like this way. Most farmers don't have smartphones. Okay, a key, and many of these farmers too doesn't really have reliable data either. So a chatbot actually needs someone to open an app and what type a question, and that reach might even get to something like, let's say, only 1 out of 10 people living in the world in that particular community where they are lacking access to the internet or they are lacking access to these smartphones. So we flipped the whole model, and instead we built what a push intelligence that actually doesn't wait for the farmer to ask. The system already knows what's happening on the farm using local data, as Papa Kofi said. So we've trained the system to really understand the farmer's local data and sense predictive and what prescriptive information to the farmers via what SMS. So when I was talking about, I said distribution is a key, because Kofi that is in the northern region doesn't really understand AI. They don't really care about your technology. Okay, what they care is about the problem that you are trying to solve to them. So for us not to worry Kofi to come and type big English or record, we are training our model to understand Kofi's needs so that we provide updates or push smart alert to Kofi whenever a problem arises, whilst also providing a solution to that particular problem. That is the reason why we moved away from chat to push, so as to ensure that we are building something that combines the experience of the farmers that we serve as well. Thank you.
Okay, thank you very much for such a wonderful explanation. Now to our first lady, I hope by now you've settled our first question for you. Yes, you mentioned you are a supply chain expert. Let's come to think of it. Where in the supply chain does prediction need to turn into action first? Is it on the farm or further downstream?
Okay, all right. So, so far as a great supply chain is concerned, prediction is something that is needed across the whole chain, right? But so I believe the action should rather be, or prediction, right? Should rather be focused at where there's the biggest risk. So if you go to the farm, right? Farmers, depends on rain, so they are rather waiting for rain to start before they start planting. And then if you look at how the climate has been recently, you notice that the rainfall pattern is not following the same pattern again, and that will mean that like farmers will keep on doing guesswork, right? So which means that prediction should start on farm. So farmers should be able to get a system where they can predict the weather, when to irrigate, pest control systems, when to fertilize and all those ones. Very important. And then if you look at the downstream parts of the supply chain as well. I mean, logistics, warehousing, and processing. And even when it comes to pricing, prediction is needed. Because if you are, let's say, maybe a logistics or officer or something like that, and say maybe you stock maize, and you do not have information, right? You are not able to predict when maize prices are going to rise or going to fall. It means you are going to stock more than you need, and then you're going to keep grains, and some may go moldy. So at the end, your money is going to go waste. So for me, I believe the prediction is something that is valued or should be used across the value chain. So it's not like one particular point of the chain that we need to, focus more when it comes to, using AI to predict how things are so we can avoid risk. But the agri supply chain is of the whole chain is quite risky. Hence, there's a need for prediction across the chain. Yes, but the real opportunity for me is being able to connect those predictions across the entire chain so they can be responded easier or earlier or faster. So let's say maybe if we know that it's going to say so I'll use a practical one. So for last year, a lot of rice farmers that cultivated, most of them have not been able to sell their rice. Right, a lot across the region. You go to the north, even in the middle belt like us and all that. So you notice that if farmers were able to get information, or if there's a system, right, that we're able to predict the whole chain from how much rice is needed in the markets, flowing down to what the farmers should plant, then it means you are going to avoid this challenge. Right, so farmers having produce down there, but there's no one to come and offtake them and all that. Yes, so that will be my take about how supply chain prediction, actions should come first.
Okay, thank you very much. And please, fellow participants, if you have any questions, leave them on the chat box. We will attend to them as soon as possible. Okay. Now to Papa Kofi. We know very well that in Ghana, most of our rural farmers do not have access to smartphones, or they don't even know how to use these devices. What is the hardest part of turning a prediction into something a farmer with no smartphone can actually use? I hope you get my question.
Yes, I do get the question.
Okay, thank you.
So when it comes to your question, the hardest part would be closing the human translation and then the trust gap. So what I'm trying to say is that we need to establish the trust of these farmers. And since there's a challenge of not having access to smartphones, a really effective way is to do that through USSD. So USSD applications are applications that can work on low-end devices, especially on the smartphones, and they don't require internet connectivity. So if you're on the YAM phone, as we call it, you can simply dial a short code like maybe *111# and then follow some prompts. Or you could also do interactive voice responses. So there could be a number where farmers can call and they will be able to communicate via a voice over the call. But another challenge is the fact that we need to be able to translate this multivariable weather and pest model. What I mean is that, for example, humidity, temperature, all these technical words, we need a way to translate these into our local languages like P, Dabani, Ewe, Fanti, Organ, and other 50 plus local languages that we have. So this is where a real challenge is. But also, as you look at the challenges, you look at some of the solutions, right? There's a company in Ghana currently pushing to translate English into these local languages, which will enable some of these things to be possible. Another challenge too is action over raw data. For example, a farmer doesn't want to hear 30% chance of raining and the rain amount or Yeah, the rain amount is going to be 12 mm. That's too technical, right? They are trying to understand what to do. They need action plan, not metrics, not just 100% humidity or 12 rainfall level. So instead of simply giving them the metrics, we need to give them actionable plan. So we can say that do not apply fertilizer today, but then apply it tomorrow. Because if you do, rain will wash it away, right? So that's like a clear instruction, telling the farmer what he needs to do instead of simply telling the farmer there's going to be 20% chance of rain. So we need to communicate to the farmers in an actionable way instead of giving them the raw metric. Sometimes giving a farmer the temperature level or the moisture level might not necessarily mean anything for them. So it's important to clearly communicate what it means and not simply giving them the raw information. And then the last point I like to add is that we need to actually help them to trust the system, right? And we can do this most effectively through the agricultural extension officers or community lead farmer. So, for example, if there are 50 farmers in the community and there is one of them which is like has been elected as their leader, or let's say who is very influential in the farming space, if you are able to pitch it to that leader, they will be able to influence the rest to follow through on it. So by engaging the extension officers and the community lead farmers, you are able to reach each and every one of these farmers in order to help them to access AI or whatever technology you are trying to push to them. So these are some of the things that we need to consider. And I believe these are some of the hardest things to tackle when it comes to giving access to farmers for them to access AI and technology at large.
Wow. Thank you very much for that. I think we are learning so much from today's interaction because we always see all of these as challenges, but how to solve them has always been a problem. And thank you very much for showing us the way forward. Okay, now to Erica. As a CFO, how do you tell a prediction that is actually useful from one that just sounds impressive? So we have predictions that are actually useful and others, like he mentioned earlier, technical terms being used to impress those who understand, but to the local farmer, we don't understand what exactly it means. So how do you tell the difference between a prediction that is actually useful and the one that just sounds impressive?
Okay, all right. So, how I tell that as a CFO, for me, if a prediction has numbers attached to it, then I know it is something that I can work with, right? So, I did mention that we make agric machines and all that, right? So I'll use an example for that. And we also have the service aspect of my business operations. So assuming maybe I'm there and I get a call that, oh, okay, so a lot of farmers are planting rice in this, maybe in Ashanti region, right? I mean, that is quite interesting because for me, I do not see that as a prediction. Maybe I'll just see it as an interesting information. But if I'm to get numbers attached to it, that is when I can make a decision based on that. Right. So for me, a prediction is valuable for me especially if it tells me what action to take. So if I get the information, okay, so there are farmers that are cultivating maybe 5 acres of maybe rice, right? Then I know, okay, if they are cultivating 5 acres of land, then it means I can dispatch one of my machines there and then I can get this amount of money, right? And then for me, prediction becomes valuable when it tells me how much something is going to cost. So it boils down back to the number that is attached to it. Because if you get maybe an interesting prediction, it can be a trend. I mean, it's just an information that is passing. But immediately we attach numbers to it, then we know that that is something that you can allocate resources to, and it's something that you can, leverage on a business, right? Because resources we know is scarce, right? And so if you get a trend and then you just follow it blindly, like maybe there will be information out there, people are going to buy a lot of tomatoes, right? Who is going to buy the tomatoes and how much tons do they need to buy? So you wouldn't follow that they are going to buy a lot of tomatoes, but then you follow a prediction that says, oh, okay, so maybe there's a new processing facility that they've built, and for this year they are going to need maybe 20,000 metric tons of tomatoes. That is something that I see as a prediction, and that is something that you can measure, right? It's something that you can, you can ascertain, or you are certain, right? That there's something that you can work with, right? So for me as a CFO, that is how I see that a prediction can be useful, right? So that would be my answer for this.
Okay. Thank you very much for that. Okay. Now to Congo. During your first presentation, you made mention of predictive plus prescriptive, or the differences between prediction and prescription. Can you please tell us what predictive and prescriptive means in one clear example?
Okay. Okay, awesome. Thank you once again. So, when you talk about predictive and prescriptive, we are basically talking about two different things altogether. And basically, predictive means the system spots, for example, the system actually spots a problem, okay, before it happens. So the system actually tells you that, hey, there is a problem actually here before it does what it happens. Now let's look at the prescriptive. So the prescriptive basically means that it tells you exactly what to do about the problem. That is the actionable steps. When Papa Kofi was explaining, he made mention of the actionable steps, moving away from prediction to to prescriptive. So one clear example is that, let's say a maize farmer is more like 6 weeks in, okay, and the system sees the yield trending very low, and that's the prediction, what the system actually sees, okay. But instead of just maybe flagging something that something is wrong, it tells the farmer exactly what to do. That is the prescription, okay. The predictive actually tells the farmer, hey, there is low yield here, whilst the prescriptive actually tells the farmer what to do. So in all, the prediction basically tells you something is going on wrong, whilst the prescription tells you what to do about this. So more like moving from in the way of being more predictive to prescriptive aspect of serving our smallholder farmers. Thank you.
Wow. Okay. Thank you very much for that too. Okay, I hope we are learning and we already have so many questions boiling in our heads. Please keep them in the comment section. We'll attend to them very soon. Okay, now back to Kofi, Papa Kofi. Years from now, what will good AI agriculture tech look like that we don't have yet?
Yes. So when it comes to good AI agriculture tech, there are a number of things I could mention, but I'll just pick a few. So first of all, we can talk about local microclimate forecasting. So what I'm saying is that right now you can have weather forecasting, like the general weather forecasting, but you need a situation where it's actually hyper-local, which means it is very localized to a particular farm. This is important because the current models that we have can estimate weather over wide areas, for example, 10 to 25 square kilometers of area. But like if your farm is on a smaller area, you need specific and precise forecasts that caters to the needs of your farm and not just a bigger area, right? So this can be implemented by low-cost ground sensors, which are able to actually take local data and give you accurate, data on forecasts. And working with imagery from satellites is really important. So the Europe Space Station and NASA and other agencies have satellites which take images of the ground. These images are actually accessible, and we can train AI systems or AI models on these images so that they are able to provide predictions on the weather, the soil types, and so on. I mean, there are a number of people working at this, but I believe there's more work to be done with regards to this area. And then another thing is being able to grade crops, crop quality, or even leaf quality. For example, you should be able to tell whether your maize crops are diseased or not, right? And sometimes you can do this through AI actually. If you're able to train AI models on being able to detect whether a leaf is diseased or otherwise. And I don't know if I could show a 3 minutes video on this. Congo, am I able to do that? I would like to probably play a video.
Yeah, you can.
Yeah. All right, let me just pull that up. So this is okay. Before I play the video, let me just give an introduction. Right, this is work done by CSIR, Council for Scientific and Industrial Research, and I'd like us to look at it. So I hope you can see my screen. I'll play it.
Hello, welcome to a demonstration of the maize disease detection app. This can be deployed via your web browser on your PC or via your mobile phone. So once you scan the QR code, which I'll show you in a minute, it is deployed locally on your phone. This research was carried out with a total of 1,083 samples of data collected. This consisted of 305 healthy leaf samples, 264 leaf samples with the common rust disease, and then 215 leaf samples with the streak virus disease. Just to give you an idea how these diseases look on the leaves, when I select one of the samples of the streak virus, this is how it looks like on the right side. And when I select a sample of the common rust, this is how common rust looks like. And to give you an idea of how an average healthy leaf looks like, this is how it looks like. So that is the data that was used in carrying out this research. Now the methodology involved the usage of a neural network architecture, which consisted of the input layer, 2D convolution pool layer, which had 16 filters, 3 kernel size and 1 layer, and then a 2D convolution pool layer, which had 32 filters, 3 kernel sizes, and then 1 layer. Also the flattened layer, which generates good output, and then the dropout, and then ultimately the output layer. So in all, we had, or we have, as we speak, 91% accuracy, and almost a near zero loss. So not perfect, but not bad either. Quite good, I should say. So that is for the classifier. So once you have your app, how do you use it? So we go to deployment. So one of two things, if you have your mobile app, you could just scan this QR code and it is deployed on your phone. So that's what.
Well, yeah, so I'll send the link to the video so that anyone who wants can check it out later. So just to save time, I'll just cut the video short. But what I was trying to demonstrate here is that efforts are actually being made, and it's not just a matter of theory, right? These are actually things that are being done. This is a government institution, right here in Ghana that is building this application. What it does is that it enables farmers to detect diseases on their maize crops, and this is done through AI. And you can see that it has been given more than 1,000 images to be trained on. So practically, this can be done, right, as we can see. And this event is actually meant to create awareness of such possibilities and for us to look into how we can explore such possibilities. So good AI in agriculture means these things, and we shouldn't think that it is far from possible or it is somewhere far in the future, but it's closer to us than we actually think. Yeah.
Okay. Thank you very much. Erica, we are looking out for prediction and action. As Congo rightly said, we predict and prescribe. Where do you see supply chains of African agriculture 5 years from now if the prediction and prescription model spreads?
Okay, so if this prediction and then prescription spread for Africa, I would say then supply chains are going to be less reactive, because for now everything we react after whatever has to happen has happened, right? So we react after there's pest infestation, we react after there's maybe flood in the farms or whatever challenges there are in the supply chains. But if we are to move, and we actually work with this predictor and act in the next 5 years, then it means that whatever it is that we are going to do, right, we are going to first predict, we are going to be able to schedule activities rather, right? So we will not sit for something to happen before we try to look for solutions to it, but rather we prepare beforehand. So maybe I'll give an example. For my business, for our nutrition or our services part of the business operations, we mostly wait for farmers to call us, right? And then we respond to their calls. So if farmers who have harvested, then we dispatch a machine to the farm. But if the next 5 years we're able to have this predict and act, then it means that we'll be on the way before the farmers will even pick a phone to call us, right? It means that whilst we know she's planting like maybe she planted maybe in August, so by July, we know by maybe December or something like that, she's already harvesting. So we're already on the way, right? Which means that activities are going to be scheduled. It means that before pest infestation will happen, farmers or agronomists to be able to detect and give that information out. So farmers are already prepared. And even if we look at the chains, right, if we know there'll be if we're able to predict that, due to ABCD, we are going to have glut of tomatoes in the system, that means that the farmer is going to harvest and then the tomatoes will be on the farm before the farmer will be out there looking for buyers. There will already be measures in there, right, before these activities or whatever it is that will go wrong or go right could happen, because we have those unforeseen circumstances that are also quite positive for us. So I believe that in the next 5 years is how it's going to be able to predict and then it means that we are going to have fewer post-harvest losses. It means that somebody is ready to pick it up, and there's already a market that is waiting for that crop. Therefore, we do know that the post-harvest loss is just going to be reduced. It means that we can be able to trace produce across the whole chain, right? It means that farmers are going to sell or they're going to plant based on demand, not guesswork. Not the fact that it's maize season, let me plant maize, but because the farmer knows that there are this number of quantity that's the market is ready to buy. So today, supply chains are not like that, is reactive and all that, so we have a lot of challenges. But in the next 5 years, if we are able to work with this predict and act, then it means that we'll spend less time responding to crisis. It will not be a crisis management kind of change in the agric industry, but it will be more of something like prevention rather. Yes.
Okay, wow. We really can't wait to experience this in the near future because it will go a very long way to help us as farmers, most especially to deal with crop diseases and the post-harvest losses that occur. All right, now to Congo. Your question is, what has to be true? Is it the data, like we all mentioned? Is it data we are really interested in? The trust or infrastructure? What at all has to be true before the African agriculture is able to execute some of these predictions and prescriptions?
Okay, so before I start, um, is it Faustinos or something? Sorry, Faustinos, right? Yeah, I saw a question that she raised, and I think this somehow answers her question. So to be true, okay, to have something that is really truly maybe trusted, it actually comes down to three things. So one, we are looking at real local data. We are looking at the delivery, not just any delivery, but delivery that actually fits how people actually communicate. And the last one too is the word trust, and the trust that we can also what explain. And let me give, let's say, a quick picture of what I mean. Okay, so imagine you know exactly what a maize farmer in Ashanti region needs. Okay, because you've got real data, so you're an extension agent there, so you know exactly what the farmer in Ashanti region needs, because you've actually gathered some real data on the ground, more like the rainfall pattern, the planting dates, and even you, the agent, too, you always log your visit there. Okay, and the system, we have a system that actually tell the farmer with confidence that, hey, apply fertilizer before Thursday rain or something. So you see that now the picture is that the data that we have in Ashanti region, okay, is mainly tailored to the what ground data, that is the farmers what location. Now picture a cocoa farmer in Cote d'Ivoire.
Hold on, there's an echo from somebody.
Hello. All right. Okay. So the data that we have in Ashanti region, okay, they are data that is real data that was collected on the ground, okay. And now let's picture a cocoa farmer in Cote d'Ivoire. Here we are looking at the African context, okay. So more like in Cote d'Ivoire, or a cassava farmer in northern region, okay. They all have the same idea, but you can see that they have completely different soil. They have different completely rainfall pattern, and even different local input costs. Okay, maybe their language, not maybe language too is what entirely what different. So if you just copy and paste what worked in Ashanti region, we'll be giving the farmer a bad advice, okay, with total confidence. That is why earlier on, Papa Kofi said something that some farmers doesn't really focus on what metrics, okay. So it's like the information you are giving to the farmer, you are just giving the farmer a bad advice with what total what confidence, and that even worse in your case of giving advice at all. So before this becomes normal across, let's say, Africa, or becomes something that we can trust, three things have to be true for every new maybe region. Okay, so for example, you are building an infrastructure to make AI predictive and prescriptive across Africa. You need to make sure that the data that we are collecting, they are data that are gathered on ground. They are not any generic what data. We need the delivery to work for how people actually communicate there, whether through USSD, through local agents, through voice, whatever that fits for them, we give it to them, not just an app. Okay, so in every recommendation that still, and also every recommendation becomes what's explainable. As we said, we don't need to give the farmers let's say a generic metric that they can't even understand. So for them to, or for it to be trusted across Africa, one, we need to have real local data built and collected on ground. We need to ensure that there is trust. And how is the trust being ensured? It's being ensured by what? The delivery. They basically understand what you're trying to what, communicate to them. And most importantly too is the words the mode of what the distribution. So it is not really about scaling much technology when it comes to trust building. Okay, it is about what? Scaling the trust, letting them see the value you provide before they can even understand the technology behind it. Thank you. Cynthia, are you there?
Yes, please, I'm here.
All right.
Yes,
So,
thank you very much for your insight. Please, Faustinus, is your question answered?
You could have addressed the data.
Can you please work on your? We are getting feedback.
The echo is because most of our mics are on.
Sorry.
The echo is because most of our mics are on.
Okay, so let me mute myself so that you are able to talk. Thank you.
Yeah. Congo just mentioned that we need ground data, but here is the case that we are in a continent where data is an afterthought. That's if it's even thought about. So for Ghana, for instance, in my text, I mentioned that we only have 11 Met stations that record data, okay? And that's really bad looking at the size of the country and some of the things we could build with data. And there are also open data sources that are on a global scale, but sometimes we look at the resolution of these data sets and it will be really bad to use it for local applications like we are discussing. And these data sets are also trained on local data somewhere else. Okay, so some of us here are into machine learning and all that. So you realize that such a model would be very accurate when it's being used to predict scenarios in the location that the training data was. But if you try to use the same model at a different place, so for us in Ghana here, it will be really bad. Let's look at Open Meteo. It's a data source for meteo data. We also have chips. It's a source of rainfall data. So most of these data sets are really accurate. Okay, they are scientifically backed. A lot of research is being conducted with them. But if you want to monitor it, which I have done personally, like I mentioned, I'm an AgriTech enthusiast. I'm working on a couple of projects. So I've been monitoring these data sets. You realize that, okay, today they could be raining in Accra, but the Open Meteo would not forecast a rain. Or if Open Meteo forecasts a rain, especially when it's below 10 mm. So most of the time, it says that there's rain, but then on ground, the on-ground reality, there isn't any rain because the model is like a physics kind of thing. It predicts depending on the state of the environment. You also mentioned satellite images and stuff being used to do that. So the data from Open Meteo uses satellite imagery for that, but it's still inaccurate. And I really don't think it would be good for us to kind of use those data sets to build systems that will be advising local farmers and would have to give them some level of confidence. You would see that some of the times you would have inaccuracies over there. A lot of good works are being done in Ghana, okay? A lot of people are working on innovations. But another thing that is not going on well is that these innovations and technologies are fragmented. So like the video you showed, it's from CSIR. I've never seen it before. I know CSIR, but it's kind of disheartening for me that a government agency is sitting on this beautiful product, but I don't know when they worked on it. It's not really out there for everyday farmer to use. I don't know how many people on this call are also farmers. I am a farmer. I farmed a couple of years ago. Yeah. So you would also see that the people that will be using the system probably are not on this call. So sometimes we build products with the end user in isolation. So
I think you guys are doing a good job by looking at how the farmer will use the products. You are looking at digital literacy and all that. But sometimes USSD and SMS, they are overrated, if we are to be honest. Some data or information that will be really useful for a farmer, you can't transmit it via USSD. Let's go back to satellite imagery. You can actually.
Okay. Sorry. Can you hear me? All right. Yes. We are sorry time is not on our side. I think yes, we understand what your explanation is towards, but it's unfortunate we don't have enough time. So please pardon us. I hope we've gotten what you have kept across. We will have time for this next time to get more of your insights on the project or on the webinar discussed. But because of time, I think we should move forward to the next question. Our time is past the time we are supposed to close. Okay. Yes. So to Papa Kofi, how do you build a system that keeps working without steady internet or power? Yes, because we know we are dealing with the local farmer, and most of us live in remote areas where we don't have steady power or internet connection.
Yeah.
How do you intend to build a system that keeps working without these necessary connectivities? Thank you.
Yeah. So I'd like to show something. Let me share my screen again. I think time is fast spent, but then we can do something. Yeah. So let me do this. I hope you can see my screen, right?
Yes, please.
Okay, so I'm going to talk about how we can do this. So in Africa, we still have significant gaps when it comes to our network infrastructure. What I mean is like, still in some places, access to internet is still a challenge. And for engineers, it's important for us to be able to reach those we need to reach, regardless of the challenges that exist. So this slide here shows an architecture for offline first, edge first solutions. So if you look at a bigger circle here, we have the energy, right? So before you can power any electronic device, first of all, you need energy, right? And we are going to assume that the place is a remote area which lacks access to electricity or probably inadequate electricity, and then low connectivity or no connectivity. So with these challenges, what you can do is that you can get devices that can be powered by solar, and you can also use low power MCUs. So MCUs are simply like low power microcontrollers. Low power means that they don't use a lot of energy. So even if you have a battery pack or a power bank, you can still power them up. And then GSM. GSM is the normal, how should I describe it? Telecell and Vodafone, their network services are GSM, right? And then they have internet services. So GSM is the other way of communicating via SMS without the need for internet. And then when it comes to the second layer, I have local storage. So traditionally, when using applications, what happens is that your information gets to a different server by communicating with the internet, right? But in this situation, assuming there is no access to internet. So what happens is that the information that you input on the application gets stored right there on the device. It doesn't go anywhere. So it gets stored locally. And then what happens is that when you get internet access later on, it gets synchronized with the backend servers. So in that way, you don't necessarily need access to internet to use the application. But whenever you come online, you get your data synchronized with the backend servers, right? And then when it comes to the inner structure. You have edge devices. So there's a framework called TensorFlow Lite. This is a bit technical, but I'll just speak about it briefly. TensorFlow Lite is a library that helps us to train artificial intelligence models and also run models on edge devices. So if you have an Android device, you don't necessarily need to communicate or have internet connection to use AI. Your phone's CPU or processing power itself can serve as an AI for you to use. So by doing this, you are able to integrate or able to give access to people who have or who lack access to internet and even power, the ability to use AI technologies in a way that helps them to solve some of their most pressing needs. Yeah.
Okay. Thank you very much, Papa Kofi, for your insights. Now to Erica. Please, are you with us?
Yes, I'm here.
Okay. So what role does the trust Congo is play in getting a farmer or supplier to actually act on prediction?
Okay, so when it comes to technology, so my voice is okay. So when it comes to technology adoption, trust is everything. From my experience with farmers, they really don't have issue with the technology itself, but trust is the issue, right? And so for farmers, right, mostly when you go to maybe a new farming community with new technology or anything, you go through, let's say, maybe an extension agent, because extension agents are who farmers trust, right? Farmers trust extension agents a lot from my experience, and they do trust recommendation from their fellow farmers, right? And so for farmers, it's experience. So if you are bringing a new technology, right, and then you tell them, oh, do this because it works, they are not going to work with you because they've not built trust. That's what their previous experience is telling them, right? So trust is everything, especially if it's a new technology, because for farmers, right, what they believe, or even across the chain, or even individually, what we experience shapes how we see things. So maybe if you have given farmers or whichever actor in the chain negative information consistently, it means next time they will not even believe you, right? So I would say that trust is everything, and trust is built from consistency. When you are consistently right on certain things, like maybe you told farmers that in this maybe August, July, there'll be for maize farm, maybe they'll say you gave them information that there'll be 4 armyworms, so they should apply A, B, C, D, right? And farmers waited, okay, June, July has come, July, like we are entering August and there's nothing. I've spent money to go and buy A, B, C, D. But what you told me will happen or not happen, then it means that next time if you are going to tell them something, they are not going to believe it, right? So trust is everything. And then if we are bringing new technology to farmers especially, you need to be as honest and transparent as possible. You don't need to exaggerate about the capabilities of whichever technology you are going to give them, right? Because if you exaggerate and they take your word for it for the first time, next time, even if what you are bringing is, you are not even exaggerating, you are maybe understating whichever technology you are bringing a potential, they are not going to adopt it, because first the trust was broken. You told them this will happen and it didn't happen. Maybe I'll use the example, right? Ghana Met will maybe predict that it will rain, will not rain, and all that. People do not believe, because last time they said it will rain and it didn't rain. But then what they are saying could actually be true. So until you are honest, or like you are consistent in whichever information or predictive action or whatever information that you are giving farmers consistently, right? That is when trust will start from. When that's when next time when we bring them, even something that's so outrageous that they can't use, they will be quiet, listen, and then work with it. Because if for nothing, their previous experience told them that whichever information or whichever technology you are giving them works as you have predicted. And I'm thinking to add to that, most times when we send technology to, farmers or other chain actors, right? Language is very, very important. If you go to maybe a farmer in, maybe I'll mention some of the rural communities that I operate in, let's say maybe Afayime, and you tell them, oh, like you are bringing maybe something so simple, maybe dry your crop to this percentage before you store, so then it will not go moldy when you are mailing, or it will not go moldy when people are buying. It should be in the language that they understand. You don't need to go and impress them with big languages, because immediately your languages are big, they see a barrier there. Therefore, they will say, oh, they don't know what they are saying. Right? Even though you are telling them something that is actually true, or you are bringing them a technology that could actually change how operation is done. So language too builds trust. Right. And then most times, if it's a new technology you are bringing to farmers, then it's best to go through recommendation that farmers can verify. So maybe I'll give an example. For most of the farmers that we get from my business, right, it's mostly from recommendation that other farmers have told. Oh, those people, they are very good. Their machines work as they have said. The next thing, you'll be there, somebody will call, oh, this person told me you do ABCD, so come and do the same thing for me. And that is how technology should move, because recommendation means that there's trust. They can verify that whatever it is that you are bringing them works or operate as you are saying. So yeah, if let's maybe you are using AI, predictive AI, to tell farmers that, oh, harvest your tomatoes when it's maybe green, almost turning red, right? They need to know why, because they've been harvesting tomatoes when it's red all along, right? So you need to add why this technology is telling them to do whatever it is that they have to do. So the next time, if they are doing it, they know that, okay, so this is the reason I'm doing A, B, C, D. So for me, it is trust. It's not the AI or the predictive or the technology that you are bringing them that is the problem, but it's the trust that they build around whichever technology that you are bringing. So it means that trust is everything. Trust is everything when you want farmers or supply chain actors to act on, like, especially the AI or prediction or whatever technology that you are introducing to them afresh.
Trust is the main tool. Okay, thank you very much for that. Yes, sorry, Dauda, I have seen your hand has been up for some time. Kindly let us wrap up with the panel discussion before you ask your question. Kindly note it down. You will be given the opportunity to ask your question in the next few minutes. Okay, now to Congo. You are supposed to walk us through what a farmer actually experiences when a prediction turns into an action. I think all these somehow have been spoken about, but in just some few minutes or even in a minute, just take us through what a farmer actually experiences when the predictions turn into action.
Okay, so given the opportunity again, so I'll make this brief. So in terms of what the farmers or a farmer actually experience, for the farmer themselves, um, none of this feels like technology to them. Okay, it just feels like getting a good advice at the right time, basically. Nothing like technology to them. So as I said, let me walk you through. So let's look at an agent who visits a farm each day, and the agent logs few things, more like what happened on the field, the planting date, what's been applied, and even a quick photo. Okay, and that data basically runs in the background, something the farmer doesn't see. Okay, great. And later, a day or two, maybe that farmer gets informed about how the farm is doing, or as Erica and Papa has been saying, maybe the rainfall pattern and everything, how the person should apply the fertilizer. This one, there is no app for the farmer to open, no question to ask. The farmer simply just get an advice at the right time. So he doesn't even know more like there is an AI behind this. Okay, because in Ghana, we know that smallholder farmers forms the major backbone in terms of food production. Okay, and if these farmers contribute to the majority of producing our food and everything, whenever we are building these solutions for them, we think about the distribution aspect. So they basically see or have what to do and they act on it, and they doesn't even understand the technology behind it. So to wrap everything up, the farmer himself doesn't even know there is any technology behind whatever that the person was doing, and hopefully he just gets a message or just gets any alerts through any means, and he basically acts on it. That is the scenario on how farmer really actually experiencing these technologies. But most of us, let's say earlier on, Papa Kofi was mentioning about when we hear AI, we started using word chat. But as I said, most people really understand or think of AI more like these drones and others. But no, these farmers experience it different way as we think it is. They just want to what act, and that is why we are trying to move from the prediction to the action. Thank you. Hello, Cynthia.
Yes, hello. Sorry, I muted without. Okay. Yes, thank you very much for such. Yes, so a follow-up question for you. You spoke about what we are supposed to experience when predictions are turned into action. And Erica earlier on stated so many things that will determine whether a farmer adopts and implements your innovations or they decide not to. Now, what do you think is the biggest risk of AI in agriculture overpromising? So, like I think Erica stated that if we overpromise them some things, we stand to lose in the future. What at all is the biggest risk if we overpromise using AI in agriculture?
All right, there is one thing that we can all take into consideration in terms of retention. Can you please
Sorry?
can you mute yourself, please?
Okay.
All right, so even in, let's say, an entrepreneur like selling something, there's something called the what retention. Okay, so and let's look at what I'm trying to say. The biggest risk mostly isn't the technology itself. I think Erica has explained everything. It is more about the words. The like is the technology being wrong with confidence. So in farming, let's say a bad recommendation doesn't just waste the farmer's time. Okay, it can cost, let's say, someone their whole season. For example, the risk is the type of confidence you are trying to build in the farmers. You went to a farming community, or let's say your AI predicted a certain solution that actually wasted the farmer's time. Okay, it is a very 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 biggest risk in terms of what agriculture being what over promising. So imagine the system tells a farmer to let's say apply a certain input, um and also like should apply a certain input, but that particular advice wasn't properly grounded. Maybe it was maybe guess. Okay, maybe your data was being, for example, you gathered data in northern region with let's say millet farmers, and you provide that same data to train your model, okay, for farmers in another region. Because that data in some way is not validated enough, the farmer will first of all trust it. That is why I said that the farmers themselves doesn't really know there is technology behind all this. They don't really know there is AI. They think you are providing an advice to them, so the farmer basically trust it, acts on it, and even let's say they harvest and they surface. That farmer won't just lose trust in that particular one message that they receive. Okay, they are going to lose trust in the whole platform, you yourself, and there will be like something like this. Erica mentioned of a recommendation. Okay, once the person loses trust in you, there won't be any recommendation from the person. So The biggest risk, to sum everything, the biggest risk is basically the trust. Okay, giving them a false confidence in even a single advice that you provide to them. That is why every single rule we use, or let's say we are trying to build, we need to build with what? Real agronomist, okay? Not something like a guess model that you want to build. You understand? So that you build something that is very reliable and clever than being, let's say, too confidential and what? And wrong. So the major risk in terms of agricultural being overpromised is basically the trust behind the whole system that we are trying to build. Thank you.
Okay. Thank you very much. Okay, Erica, what is a supply chain problem today that better prediction could solve?
Okay, I will go for post-harvest losses. I mean, if you're able to better predict when to harvest, when to transport, when to sell, and everything, then it means that we are going to cut down on post-harvest losses. So, most of the spoilage or the post-harvest losses that we experience is from the fact that we are, or farmers are unable to know when exactly to harvest, right? Or when, like, what quality or what postage should crops be harvested and all that, in terms of how they can even store or contribute to post-harvest losses. So if we could actually predict when we can harvest and all that, then it means that we are going to address a lot of challenges even across the whole chain. So if I'm to pick one problem today, I'll pick the harvesting. However, if we are going through the whole chain, then it means that it's the whole chain. So from the harvest, from the farmer's side, maybe the harvesting timing, and then if we come to the logistics in terms of when produce are in transit, right? I believe all of us have been observed situations whereby maybe you are traveling, you see a truckload of tomatoes have stored somewhere, and then they are fixing. By the time they'll be done fixing, about 50% of whatever is in there has gone waste. But if you're able to predict, track the trucks that are even transporting the produce to the market and tell if the trucks are even functioning well, then it means this challenge of post-harvest loss is not going to happen in the first place, right? And then where we could also optimize prediction can be the warehousing, in terms of how we store produce, even the quantity that we should produce and when produce should be, moved out of the warehouse is also very important, because we have those that keep produce in there. They do not even know the moisture content at which such crops should be stored, right? Which means that if we are able to predict all those things, then it means post-harvest loss is still going to happen there. And then being able to actually predict the market too is very, very key. If you know what produce is in demand, then you'll be able to produce to seal that. But if not, then it means you are just going to do your own thing somewhere. Tomatoes might be in glut, and then you keep on bringing in tomatoes. It means that you are going to lose some crops, and then you are going to lose money, right? And so even to the point of processing, so those who process maybe let me not go big with the nurseries and things, but those who even process maybe tomato paste and all those ones, right? They also need to be able to predict their processing schedule, since they are all in the chain. Because if you don't know when to process, if there are no produce, or let's say maybe a produce is scarce at the moment because of maybe rainfall issue or whatever it is, then it means that your machines are going to run, you're going to run at a loss, and then a whole lot of things is going to happen. So reducing post-harvest losses isn't just about getting a better equipment, or putting in the right technology and all that. It's basically about making better decisions, and you are best able to make better decisions if you have the information at hand, or you're able to predict what will happen in the future. Hi, Cindy and Alexander.
All right. Thank you very much. Now to Papa Kofi. Tell us, how will you make an AI recommendation explainable so that a farmer or an investor can actually trust it? I remember Erica spoke. Now we are talking of AI, something you can't see, something you have no experience or real world interaction with. How do you explain it or recommend it to a farmer or an investor to trust it?
Yeah. Once again, thank you very much. So just as Erica mentioned, it's really important, right? It's one of my points actually, where a farmer would be more likely to trust AI recommendation if it aligns with things coming from their local extension agents or a respected community leader who is also a farmer, right? So the barrier comes with people trying to trust technology. So what if they don't need to trust technology? They need to just trust another human being that they already trust. So for example, most farmers already trust their local extension officers or their community leader who is also a farmer. So our focus should rather be on convincing the extension officers or trying to train them on these tools so that they would in turn relay the information to the farmers. With that approach, we'll be able to get more farmers on board and we'll be able to reach the farmers directly. And when it comes to the question of investors are actually people who are placing a risk on a business in the promise of getting returns. In reality, any kind of investment is a risk, which means you can either gain or lose. But for an investor to make an informed decision, they will need some data, right? So AI platforms need to give clear risk profiles to these investors. So instead of simply saying things like, for example, you telling the investor that, maybe if we have 20% rainfall this month, you are going to get this amount of yield. You need to let them understand what it means when we have, up and downs in our rainfall patterns. So a statement like, if rainfall drops by 20%, our expected yield drops by 8%. That one is more clear to an investor. So that the investor is able to know that, okay, I'm investing X amount of money. And if the rainfall patterns doesn't go according to plan, then I stand a chance of losing. So we need to give them actual data that would help them make informed decisions about their money. Because this is what they are looking for. They are looking for returns. And again, there's another point that I would like to share, which is showing the why. So the information that we give should have a cause and effect structure. For example, you can say planting on April 15th is recommended because at that time the soil temperature would have reached, let's say, 24 degrees Celsius, and then our satellite data is also showing that there will be rains like for 3 weeks, right? So essentially, what I'm trying to say is that you don't just give metrics, but you give some kind of cause and effect. So the cause is 24 degrees Celsius temperature. The effect is that you're going to see rains over a 3-week period. So the information that we give to investors should be compelling information, which compels them to put their money into agriculture and helps them to understand that agriculture is really something that they can put their money in and they can benefit from.
Okay. Thank you very much, Papa Kofi. Now to Erica. So, per the explanation he has given on the AI recommendations, will you as an investor or a farmer be convinced to fund an AI recommended technology, or what exactly will convince you as an investor to invest in an AI recommended technology? Thank you.
Okay, thank you. So what I would look for Can you please?
Okay.
Okay, so what I'll look for before actually deciding to fund an AI recommended, business will be five things. So I'll look for five things, right? The first one, I'll look at if the solution or whichever AI product the person is selling to me solves an actual problem, right? So is it something that farmers can use to solve? Are we going to solve a problem with this AI in the first place, or is it just going to be a good to know product in a in an ideal way? We have this ideal product that actually do not even solve anything, right? The next thing I'll look for is there really evidence? Right. So if it's solving problem, what shows that it solves problem? Is there any pilot data? Right. When you're prototyping or you're testing in the lab, is there any data that you have that I can know that okay, so this is actually is going to solve a problem, and during the pilot stage is the data that you got. Right. Is there any feedback from users when you are piloting? Right. Is there any outcomes that you're able to measure that I can see? Right. And then the third thing I look out for will be, can farmers really use this technology you are talking about, this AI, technology you are bringing on board? Like, I think back of you mentioned about, no, your question, one of the questions about offline, software or AI predictive software that farmers can use and all that. Does it work offline? Because a lot of our farmers are in remote areas. And it means that they are not going to get internet. And even if there is internet, most of them do not even go online. You go to the field, and then most of the farmers are even using yam phones. There's no internet over there. That's whichever software or AI app you are recommending, is it having this offline feature or offline as and how about the language as well? Right? Is it affordable? Is it simple? Because it's not something that farmers will dial this and do this and go here and go. They'll give up in midway. So I have to actually know if it's something that farmers can actually use. And then the fourth one, before I decide to fund a project, will be if it can scale. If it's not something that is only helping farmers in maybe this community, but it can't be scaled. Is it something that can move from one village to the whole nation or even across Africa? Right? That is something I'll look out for. And then the fifth thing I will look out for is the impact. Is it a technology that is going to create impact that can be measured? Right? Is there going to be evidence that because of this AI, they've been increased in yields, or there's less post-harvest losses, or farmers are able to, cut down their costs, or increase their income or whatever it is. So as an investor, I would rather fund something that is evidence-based than something that is interesting and fancy and, wouldn't work out there. Thank you.
Okay. Wow. We have learned and we are still learning. Thank you very much, Erica, for that. Now to Papa Kofi, tell us, what one prediction to action tool do you wish existed in Ghana right now?
Okay. Thanks for the question. So, one big issue in the agri sector in Ghana that we have observed over the years is post-harvest losses. So, post-harvest losses is simply a situation where after harvest, the produce or the harvests are kept on the farm, and due to inadequate storage facilities, they perish or they go bad on the farm. This causes significant financial losses to the farmers. So a good prediction to action tool would be something, a tool that essentially helps farmers to avoid or at least reduce the impact of post-harvest losses. And a solution that comes to mind would be an engine which combines, satellite imagery with hyperlocal weather predictions. So satellite imagery essentially gives us data on soil and other parameters. And the hyperlocal weather predictions would also give us weather predictions that are quite precise for a particular farm. And another thing we can add is real-time market pricing, right? What's the price of, let's say, yam or cassava in real time at maybe Mokola, Techiman, Aboboloshi, or Kumasi Central? We need to get a tool that is able to centralize all this information into one unified platform, and it's able to alert farmers via, let's say, SMS. So we already talked about the fact that we want to work with offline first means, right? And then, so this means that this unified platform, which you're able to consolidate this kind of information, should be accessible to the farmers through, let's say, SMS weeks in advance, so that they can adjust their harvesting schedules or their irrigation schedules to prevent simultaneous local what's the word, gluts. So essentially, what you are trying to avoid is that different farms in the same district shouldn't be harvesting at the same time. Else, like, everyone has harvested, right? And then there's some kind of, is it oversupply or something, which actually leads to post-harvest losses, because if there's more supply than the demand is available, then people would have to keep their produce on the farm, and then it will eventually go bad. We can also talk about the fact that we can build systems which can automatically alert people within the supply chain who transport produce from the remote areas on farms to the marketplaces, right? So what we can do is that we can set up alerts, which essentially is able to give truck drivers and people who are operating cold chain technologies like fridges and traders alerts on predicted harvest days. So, for example, if a farmer wants to harvest his crops next week, a trader should know beforehand that the harvest will be ready next week, so that they're able to also prepare to actually go in and purchase these things. So, in a way, what I'm trying to say is that we need a technology that bridges the gap between the people who are actually producing the crops on the farm and the people who are actually utilizing it. That is the traders or the end users. This would help to reduce post-harvest losses in a way that seamlessly connects the two people, right? The farmers and the traders, or the farmers and the end users, or how am I saying end users? Consumers, so that you're able to reduce post-harvest losses. So I think in general, that tool would be a tool which unifies information across weather predictions, real-time markets, price data, and satellite imagery. Yeah.
Okay. All right. Congo AgriLync Nexus, as we all know, is geared towards all these practical predictions, prescriptions, and the way forward for farmers to experience better farming process and crop production. Tell us, what does the future of AgriLync Nexus look like once all these models are proven?
All right, sure. Please, can anyone hear me?
Yes, please.
Awesome. So, um, so what it looks like once this whole model is being proven is that once the predictive and prescriptive engine is proven, the real thing is not to unlock the technology itself, but is to basically unlock or know what is actually built on top of the technology, and that is trust and reach. So we know that a model that actually works on paper only matters if it can, get to a farmer in their own language, as like Erica and Papa Kofi have been saying throughout, and also through a channel that they already use, and if investors can also trust what it is actually telling them. So let's look at something here. Let's look at the trust that I'm talking about here. So first, every alert and every yield prediction that get to the farmers becomes more explainable and what traceable back to what real farm data. We are looking at all the real farm data is being applied by the what agronomist defined rules. So that is what lets an investor act on that particular what alert without even second guessing, because the information that is being given to them are what trusted. Okay, and what it also led the farmers to follow and what instructions without needing to what understand the AI what's behind it. And we do that by also leveraging on our what let's say our human agents on board as well. So we are not doing something like a pitch, but a working history of what an accurate predictions and farmers who acted basically on them. And also it will let's look at the distribution aspect too. So the model was never actually built, or we are not building a model to be centered around smartphone what access. So it's something that actually works through whatever channel that actually reaches the farmer, taking into consideration the SMS that we've spoken about, the USSD, the voice, and most importantly to the agents relaying it in person to the farmer. And what this means to us is that means growth, and this isn't blocking the device or the connectivity gap that they are facing in terms of access to smartphones or network gaps. It actually expands the infrastructure that actually it actually expands let's say it expands it into maybe new commodities, more like the crop types or the regions that we have, and it's also give it more like the same infrastructure cars what over. And the last thing too is very very important, that most these AI tools that we have built for smallholder farmers lacks. It is the language. Okay, the language in terms of what the farmer is truly understanding the system or the AI that they are interacting with. So we see that every alert is actually what's delivered in the farmer's own language, and this one is not basically not translated after the fact. It's basically something built to give them a nice feel of what everything being translated to them in their own language based on their locality. So at AgriLync Nexus, we are not building something that push farmers aside, something that actually exclude farmers. We are building something that ensures that smaller farmers are in. We are building with the farmers and making sure that we are building infrastructure that makes African agricultural investable. And once that reaches farmers wherever they are in their language they trust, backed by a system that they can actually prove why it stands out and what is being said. So in all, if this model is being proven, it's proven on three things, as I said, it's proven based on the trust, the distribution, and and the language it's also provides to them. Thank you.
Okay. Thank you very much, able panelists, for taking time to run us through all these life-changing questions that will impact us as far as AI and agriculture is concerned. As our topic remains AI and the future of agriculture from prediction to action. We are all working towards a future where AI will be able to help us act in ways that will productively impact our farming process. Thank you to our participants. I think Dauda, your internet has not been stable, but you have tried so much to stay with us. Andrew, Sedem, Lillian, in fact, thank you all for the time. I think if we, yes, so now Dauda, I think you have the opportunity to ask your question if it still persists. Then the rest of us can also ask questions if we have any before we give the opportunity to our panelists to give us their last words. So now we take questions from you. Thank you. So Dauda, if you still want to ask your question, I think you have the chance to do so. Okay, so if Dauda doesn't, or if he's not around, or we can't hear from him, can any, okay, Emmanuel Lucky Ade, can you please ask your question?
Right. Good evening, everyone. Um, Thank you for the opportunity. I really enjoyed each submission from the various panel. They were very insightful. Um, my name is Emmanuel Lucky. I'm an agripreneur. I'm into growing of vegetables and root tubers, and then also coconut as well. At in Wa Upper West and also Bono East region at Ebubu. My question is actually directed. It's an open question, so any of the panelists can actually answer it for me. Many agricultural solutions are developed in and validated in one geographical region, and then we assume that they can be easily replicated in other regions. However, farming conditions differ significantly due to variations in climate, soil, infrastructure, and what have you. Shouldn't AI and other technological solutions be designed around the specific needs and the realities of each farming community rather than relying on one size fits all approach? Um, in other words, should our priority be shouldn't our priority be strengthening the foundation of the challenges that we are already facing in Ghana than integrating a new system that farmers are yet to adapt? Because me personally, as a farmer, some of the challenges that we've been talking about, advocating for so many years, they are still there, and then I believe the integration or the introduction of a new system to these farmers, it's kind of a bit scary, because people that are building these solutions most of the time don't find themselves in the grounds. I mean, yes, we are talking about extension farmers and whatnot. My question is, how many farmers now even still uses extension officers in securing data or information? Because when you come to those typical areas in WA, they rely on micro or tiny farmers associations for data and information, right? So now that we are talking about AI integration and whatnot, who then advocates or convinces them to actually introduce such systems in their daily operations, whilst the already existing challenges that they are facing have not been solved or kept? This also arises another important question: that where does the data that power AI comes from? Who collects those data? Who validates that data? And continuously updates the information that AI uses to make the predictions and recommendations that we actually opt for in terms of the support or use of AI in these operations in terms of the agricultural value chain. Thank you.
Thank you very much, Emmanuel, for your question. Yes, to any of our panelists. Okay, so Congo wants to answer your
Thank
question.
you, Mr. Emmanuel, for your question. You asked three in one question at the same time. Thank you very much. So to answer the first question, we are asking that the data that let's say is being collected to train these models to make this prediction that we are talking about, it's more like it's being centered on one particular region. Okay. No. So to answer that particular question, or how we ensure that what works, or maybe what works in this particular region will best work for others. Great. So the approach is that, as said earlier on, training or building these AI models to make all this prediction and stuff needs data, and they don't really rely on one particular data. They need to rely on different patterns. So, for example, depend on let's say those trying to gather those information on those particular technologies to decide, okay, so we are now trying to focus on, let's say, these particular regions in Ghana. So let's pick like more like 4 regions in Ghana. That one is mainly for the validation before let's say the model gets proven. You understand? Even 4 regions is very bad. So let's take more like 7 to let's take 7 regions. Purposely we are building for for Ghana, and that particular 7 regions who collect the data. That answers your second question. Great. Sometimes it is not the developers or the engineers themselves that collect the data. Okay, we have more like the CISR and other institutions that have data, but those data get our data as time correct. So mostly it's the field agents, okay, that's get in touch with the farmers on ground through farm profiling. Okay, for example, we have a system that we use to onboard these farmers, okay? And this onboarding profile contains the same flow for every region. We collect the same farm profiling for every region. We use these data that we are collected from farmers as time goes on or as time correct to actually train, refine, and tune this model. In as much as the model will, we are not looking at here, we are not looking at 100% accuracy, but in as much as the model will prevent it what's concave, what's lost in such a way that the model is going to predict or be accurate to a maximum percentage a maximum percentage that is more like okay to use. So it is not more, as you said. It seems I'm not really diverting, but I want to cut in somewhere. So to really align what you are trying to say, it is not more like collecting data entirely. Trust me, you can get enough data on ground, okay, but there might be gaps. And how do you fill in those gaps? You fill in those gaps by constantly tuning this particular models to be to actually predict this information. And great, your third question also asks about how best we can do to solve this particular problem in terms of what you just mentioned to the farmers being. Please come again with your third question. Please, am I audible?
Yes. Hello, Emmanuel. Can you hear him?
Hello. Yes, I can.
Yeah, come again with your third question, your last question that you concluded with.
Yeah, so I was saying that aren't we supposed to solve the already existing challenges that we farmers are already facing, and
Okay.
before kind of introducing a whole system to these farmers? Because I find myself in an area where it's more of like an agricultural village, right? And then I keep on hearing, AI, and all those kind of stuff. But I believe that those gaps that we already face, I mean, on the foundation level, they've not yet been solved because we still have challenges with logistics, storage facilities, and whatnot. And then personally, I do feasibility and then surveys around the community. And trust me, you can see for yourself that most of these farmers that are doing the traditional way of farming, they are well learned, right? Any form of farming method that they are using, it's working for them. Just that maybe in terms of, I'm taking it from an angle where we find ourselves in communities where people don't see farming as in commercial purpose. They see farming as in a way of life, right? For someone who farms as in a way of life and is always only concerned about what the family is gonna eat, how it's gonna cater for the family, or maybe be able to extend open arms to and people in the community that also need assistance. How do we convince this person that, oh, maybe when you introduce AI or kind of integrate AI into operations, are going to scale up into this particular, So me personally, sometimes when I get orders from clients and then they want something and I want to source from farmers, then something that if I'm farming in a different region, I can get from one particular farmer. In where I'm farming, I have to reach out to about 15 or 10 people before I can get a certain quantity of what I want, right? So when you're introducing a system, you also have to look it from at an angle where people also farm as in a way of life just to cater for their family, not because they want to kind of, do big things. I mean, you're talking about modernization, and we the youth that we see or talk about agriculture have a different perception about agriculture. Like we see us in the new gold business. People are talking about agriculture, and all those kind of stuff. But it's like we are giving a solution to two different categories of people: people that are thinking about the commercial purpose and people who are also doing it as in a way of life. When you come to work, the conversation is different. When you go to Upper West, North, and the rest, the conversation is different. People that are doing share butter, processing share butter, the conversations are different because they are doing that. Some are doing that because they just feel bored and then they just want to do something. They want to learn a skill because these areas are places that they rely on their breadwinner, that's the husband, right? So then again, you are talking about you collecting data and whatnot, but it's like the data that we've been taking, and then the solutions that are coming out, it's like it's targeted to a certain group of people. And then when you go to the upper part of Ghana, it's like we are not really seeing the implementation. You get it. So it's like the value chain is quite different from what's over there, and that's around the middle belt and also the coastal area of Ghana. So my question is actually centered on, aren't you supposed to focus on the fundamental challenges that we've already been facing? That's the logistics, expensive fertilizers. There's no subsidy of fertilizers for farmers now, and all those kind of stuff. Aren't you supposed to focus on that? And then if you are supposed to introduce something new, then we can talk about AI and IoT, right? Internet of Things. We can introduce those stuff that, and IoT kind of give more of like, I'm not a tech nerd, but I know that IoT more of like give more of like valid information, not unlike AI doing more of like the predictions ones, right? Me personally, I do freelance for CSR, and then taking data from people is one of the difficult challenges that we're even facing now. We are CSR now, we are running a survey, right? And then even calling people to take data from them, it's something else, right? So yes, CSR is there, Ghana data, and then the rest agencies are there to get data and all those kind of stuff. But sometimes on the ground level, it's quite different. Yeah.
All right. So I got your point. Okay. And basically, when you want to actually, disseminate this kind of AI solutions to farmers, you don't lead with the AI. You lead with what a specific problem that they already have, and you let the AI be what's invisible. Okay. So as you are saying, how do we solve their local problem they face before even trying to implement our new technological solution? It's very simple. What you don't lead with what AI, you lead with what the specific problem they face. And you're talking about Upper West not being more like being explicit with what data being trained for our models. I don't know the okay, we'll come back to that one later. Okay.
All right. Any other question from our participants, or if any of the panelists have something to add to what Congo has said?
Yes, I would like to add something small to the last question. So yes, it's very important that we solve the problem that is already existing, and that's a very valid point. What I actually think is that AI is not like maybe a replacement or fixing a broken system or something like that, but it's rather that is helping us solve the problem that we have effectively. Right, so it's not like we are bringing a new technology, like do AI, like maybe a new technology that's solving something new or whatever it is. You made mention of IoT, which is very true. IoT will take the information, like, that you are giving it, right? And then it's communicating with other technology, whatever it is that you have, or whatever system that you have in your farm as a farmer, and then able to better make quality decisions and all. So the AI that we are talking about is something that is going to aid, right? It's not like something new, like maybe we have the price of fertilizer you are saying has not been subsidized, which is true. So the issue now is how do we make sure that we use AI to better predict, or maybe get data that we can take it into policy that, okay, so look, these are maybe the prices of fertilizer maybe over the years. This is how much quantity farmers are buying. This is the challenge that farmers are facing. So they aren't able to maybe afford the fertilizer or whatever. So reduce the price to this. So AI is from my experience, it's more of like it gives you like the data that it is taken from you, let me put it that way, right? So you are giving it data and it is giving you recommendation based on what you are giving it. So it's not like we are bringing something new and then it's going to solve maybe a very new, challenge, or we are trying to bring in maybe what works in, like, outside the country, because for them they are quite advanced and their great challenges, or the challenges in their great supply chain is not the same as it is. Even in Ghana, like you mentioned, solutions that work in the northern part of Ghana will not necessarily work in the, the middle belt, the Ashanti and the Eastings and all that. Yes. So it's not like, maybe when we say AI, it's not like adding some complexity or we are trying to be maybe fancy or whatever it is, but finding a better way to predict activities. Right. So if, let's say, maybe we have a data that farmers will just enter, maybe this is my farm size, I planted today, I did this, I did that, I did that. Well, I was able to harvest this quantity this year, it rained at this point. Right. So all those information that you are taking is the same information that the AI is going to use to predict certain certain actions or certain patterns. So it will study the pattern over a period based on the data that you have given it. And then it will make that recommendation based on that. It's true that we have some AI that are trained on data that is not familiar to other regions and all those challenges as well. Those ones are very valid. But I mean, if we take maybe post-harvest losses in Ghana, for example, right? We know that post-harvest losses mostly will start because maybe harvesting is not done at the right time or not done well, or storage is not done well, or maybe there was some transportation issues, or some maybe the truck broke down on the way and then the produce wasted so much time or something like that. Yeah, so those are problems that we know. So AI is not maybe going to say, oh, let's build better storage facility or whatever it is, but it is just going to help farmers know that, okay, if you harvest it at this time, right, and even if the truck breaks down 2 weeks on the road, the produce is not going to have go waste because you harvested at this time. So maybe you are making room for those challenges that happens across the chain, right? So it's not like we are saying, oh, okay, let's stop the issue of this and maybe build better routes on and all that. But it's just giving farmers or chain actors like better information based on whatever like challenge that you are feeding it. So that is what the AI, is coming to do, or like we are talking about. So it's not like maybe we are creating a new problem that we are trying to solve, but we are using a new tool to solve an old problem. So we have all these challenges for a long time. Now there's AI. How can we leverage this AI to solve the challenge that we've lived with for as long as agriculture has been in Ghana, or I mean, as long as these challenges have existed. Yeah, so that's what I have to add.
Okay, thank you very much, Erica, for adding this up. Emmanuel, I hope your question is answered. Okay, yes. So, yes, you're welcome. All right, I think because of time factor, we will take our last question, if there is any, before we draw the curtains to today's program. Because, okay, Edu Evans. Yes, you can ask your question, and that will be the last question for today. Thank you.
Okay, so talking about the integrating AI into a farming system. So can we just think of a system where the financial capabilities or the finances push into the farming system, so that a farmer will later on be able to calculate or have all the expenses, or he or she push in the agriculture.
Edu, please, can you come again?
Yes, I think I didn't also get the question.
The network is bad here, that's why. So let me come again. We are talking about how a farmer can get a precise or accurate data to harvest, or to, let's say, plant a crop or to farm. So can we also get a system where the farmer will be able to know the amount of, let's say, money he or she has pushed into the farm, and the profit she will gain after harvesting?
All right, I think I now get the question. So he wants to know now, is there a way for the farmers to be able to determine the amount of money they have invested on the farm? And okay, so Congo wants to answer that question.
Okay, so I think we are more looking into the farm literacy aspect. So let's say, is there a way that we can also leverage AI to help farmers track their expenses, their gains, their returns, and everything? The question is yes, but the answer is the gap, that is the distribution. Okay, because the farmers themselves Like, think of it. How many of these farmers can read and understand all this? You understand? So if we are to, sorry, yes, it can, but the only way you can distribute this to those farmers will be through this local agents. Okay, where the local agent could easily maybe explain to these farmers whatever that is going on in terms of their what financial what literacy in what farming. Trust me, Emmanuel said something that farmers themselves have their way of doing what things that basically works for them. It is fine. Same way, we can also use this AI to give farmers this particular insight for them to easily understand or to track their expenses. But the distribution will be the gap, and we can leverage the distribution through this local agent that the farmers what interact and easily what trust, and also through training and what capacity building as well. Thank you.
Okay, thank you very much. Yes, I think we are far. Okay, okay, Evans, you want to say something?
So okay, Emmanuel was talking about how can the agent trust our system. So that's also a problem. So the farmers are sourcing from the agent. So we introducing the system to the let's say the agent. How can the agent trust our system and introduce the system to the farmers?
Okay, so agents are let's say okay, so agents, they are basically those that, let's say, the representative of people that farmers already trust. Okay, they are more like the leadership. Farmers have already had initial or engagement with them. So how this agent trust the system is that the system is being explained well to the agents. The agents have actually tried the system out to really understand the use case of it before distributing it to the farmers themselves. So what they do, they serve as the bridge between the app or the technology and the farmers. Once they understand the use cases, they understand everything, then they distribute to the farmers, because the farmers already trust these agents, and the farmers can't just wake up and trust this AI rather than trusting this agent that we've been trusting for years in our communities. So basically, the agent needs to first need first to understand the system. Okay, and how do they understand the system? They take information from these farmers to those modeling this software. So in some way, they are also helping to better understand whatever that is being built with the farmers. So whenever you are building this AI solution, one, you build with farmers, you build with agents, in order to let them have a sense of what involvement and also have a fair understanding of whatever that you are trying to build. Thank you.
Okay, thank you very much. Evans, I hope your question is answered. If so, I think I'll give an opportunity to only one of our panelists to tell us what exactly am I as a farmer supposed to do in order to work towards the AI prediction and prescription model we are trying to generate to help us learn farmers be able to have a successful farming season. Thank you. Just one of them, any of them can answer this question, then we'll take our closing remarks and draw our curtains. Thank you.
Okay. I don't know if I get the whole question, but what I will tell is it farmers, right, will be for them to start, recording or whatever information that they have. Of course, good decision is based on whichever data that you have. And if you have good data, it means you are best able to make better predictions based on past experience. Thank you. Hi, Cynthia, please. I don't know if you can hear me.
Yes, please. Thank you very much. Yes, I don't know. Can Congo, are you with us?
Yeah, I'm here.
Yes. So please start with closing remarks for us. Then from you, I think Papa Kofi will give his your last words for today's seminar in just some in 30 seconds, please. Thank you.
Okay, so to close this, I will basically start by thanking each and everyone for joining and for staying to the end. What I will leave is that AI is not something that is coming as a new thing to farmers, but it's something that is coming to help farmers make better decisions, help farmers, make or improve on their daily practices. And AI in agriculture isn't also about building something that is clever. It is basically about building something that actually reaches the farmers who needs it. So in terms of building anything farmers, we should consider the rich aspect of it, that is the distribution aspect of it, in terms of their language, their trust, and their confidence in trusting that particular business. Regarding the network issues or in the barrier, the future we are building towards agriculture is that we need to build a future that reaches this smaller farmers that we are targeting, one farm at a time. Thank you.
All right, please, Erica, your last words.
An overkill. AI is not something that is beyond us. AI is actually something that we need to explore its capabilities and how it can actually help us to efficiently produce food and solve our food security problems. As much as it might seem to be complicated and we might think that we don't have access to network infrastructure, to power, and all other challenges that might come with it, I think it is worth giving it a try. We need to explore how we can use AI to actually augment our agricultural processes. And it's through discussions and forums like this that we can drive that goal and ensure that that dream becomes a reality. So none of us should actually think that AI is not practical in our local context in terms of agriculture, but rather let's look at ways that we can use it and ways that it can actually benefit us, regardless of the specific use case. But I believe AI is broad enough for us to find a good use case that would still go a long way to help us. Because at the end of the day, what are we without food? So everything we do should be centered on making sure that we improve agriculture and we create food security for ourselves and for future generations. Yeah, thank you.
Okay. Okay. Thank you to all of us. Thank you, our able panelists. Thank you to my participants for taking time. In fact, we have spent more than 2 hours on this, and we have been patiently listening to our panelists as they discuss some of the most important things agriculture needs in order to thrive and strive for a better future. Okay, I think with this, God Rachel bless each of you for your insights, for your thoughts, for the wisdom you have poured on us, and I hope all the other participants are taking something very insightful, something very important home that will change our agricultural process for ourselves, for our communities, and for the future generation. Thank you to each and every one of you for your time once again. I don't know if Congo has something to add. If not, I think we draw the curtains to today's program. So Congo.
All right, Edu, please you can talk.
Yes, Evans, you raise your hand.
Okay, so I joined the meeting late, and from the time that I joined, I've been hearing the AI um like helping like I've been hearing about plants and crops, like integrating the AI into that agriculture aspect, but I've not been hearing it in the capabilities in like let's say the animal farming part.
Okay, so I think when Papa Kofi was talking, he made mention of disease detection. Okay, so with that aspect, we are more leveraging on the what the livestock what's as well. Okay, in as much as we predicting harvest and everything, the same way in the livestock as well too. We have AI that also does this pest and diseases what detection, giving recommendation. Some might are even trained on giving only organic way of maybe solving in terms of, let's say, when you talk about the crop organic ways of curing this disease, and instead of livestock to means of what to going about it. So in livestock aspect, we have different ways of using AI to simplify processes and also simplify your activities as well. Thank you. And to finally draw the conclusion, this webinar is powered by the Farmers Talk, and this is our second webinar. And we are looking forward for you guys to help join the next and subsequent ones. In the chat box, we have our WhatsApp community in there. You can join to follow and to stay updated with the upcoming ones that we'll be doing. Thank you so much, and have a wonderful evening to each and everyone. Bye bye.
All right. Bye bye. Have a wonderful night.